In this segment, we'll talk about the blood supply to the cerebellum. Cerebellum means little brain, and we'll talk a whole lot about the cerebellum later in the series. It's got a ton of neurons, and it's responsible for coordination. But its blood supply comes from the vertebral system via the basilar. And in this image, you can see our vertebrals coming together to form our basilar. And there are three arteries that are coming from this system that go to the cerebellum. The pica, or posterior inferior cerebellar artery, and that usually branches from the vertebral. Doesn't always, but usually. The anterior inferior cerebellar artery usually branches from the basilar, and you can see it here, and then it goes underneath this cranial nerve and goes over this way. The superior cerebellar artery, there's a branches almost at the same level as the posterior cerebral, and it comes around this way, and then you can kind of see it diving there. If this brain were tipped up the right way, like it is in your skull, this would be more superior, and this is more inferior. In the next image, I want to talk about the blood-brain barrier. Now, it's really important, the blood-brain barrier. Your brain is it's very busy, and neurons are kind of like prima donnas. They only do the one thing. They either fire or they don't fire, and they're not very good at defending themselves against insults from either the environment or anything that's, in the vascular system. The blood-brain barrier is there to protect your brain from all kinds of foreign substances and chemicals. It is created by the capillaries within the brain and by the end processes of the astrocytes. And so this is a regular capillary. And as you know from Dr. Fox's lectures, things can come and go through the capillary. There are actual pores, there are little windows, or you can have something that's being taken up and then kind of spit out the other side of the cell. And that works great for almost all of the rest of your body. In the brain, the capillaries are joined by tight junctions, and so nothing is getting through this membrane. It also is formed by the astrocytic foot processes. These are from astrocytes. They come together then to actually form a second barrier around that capillary. So most things don't get in. Some things do. Alcohol, as most of us know, some of us don't, and that's a good thing. Glucose crosses because the brain is an obligatory glucose user. It can't use anything else as fuel. So glucose gets in, alcohol gets in, but most drugs don't. So like antibiotics, it's really hard to get antibiotics into your brain, and that is why brain infections can be so dangerous. And it's also why when it comes to the pharmaceutical industry, you have to really design drugs to get into the brain, to get in there on purpose. One famous example of this, I'm sure that most of you are familiar with the disease Parkinson's. Parkinson's disease is a lack of dopamine made by a certain area of the brain called the substantia nigra. And we'll talk about the nigra when we talk about motor systems. The substantia nigra projects from the brainstem up into the cortex. Dopamine is its neurotransmitter. When you don't have that dopamine, you get the symptoms of Parkinson's disease, which is kind of a frozen kind of affect and other kinds of mobility issues. Dopamine is a very large molecule, and it doesn't cross the blood-brain barrier, doesn't get in. But L-DOPA does. L-DOPA is one of these amino acids that has a facilitated transporter. And so if you give a patient L-DOPA, it will get across the blood-brain barrier, and then once it's in the brain, your brain turns it into dopamine and helps relieve the symptoms of Parkinson's disease. And so that is one example of how you have to kind of come to a workaround if they're for certain substances to get out of circulation and into that very rarefied and specific environment of the brain. what do I want you to know about neurovasculature? I want you to know what are those two main arterial supplies to the brain. They come from the subclavian, and it's, of course, the vertebral arteries and the internal carotid. And then how do those arteries divide? What are the three major arteries of the brain? What areas of the cortex do these arteries serve? And think about strokes, and think about if any of these arteries were blocked, what areas of the brain would be affected, and then what kind of behaviors might you observe in a patient. What are the three arteries that provide the blood supply to the cerebellum? And then when we think about the circle of Willis, what are those two connecting arteries that make it an actual circle? And then what are the two cellular components of the blood-brain barrier, and why is it so important in keeping your brain healthy? And that concludes the neurovascular segment.